In this video, we will explore how to set up a data lakehouse and how to evaluate that data lakehouse is the best fit for an organization's analytical requirements. Data lakehouse is a hybrid data management architecture that combines the flexibility of data lakes with the structured processing capabilities of data warehouses. Below is a high-level guide to help you set up a data lakehouse. Define objectives and requirements. Clearly define the objectives of your data lakehouse implementation. Understand the business requirements, analytics needs, and goals. Identify the types of data sources you'll be dealing with and the desired outcomes. Choose a platform. Decide whether to use on-premises infrastructure or a cloud platform. Cloud platforms like AWS, Azure, and Google Cloud offer scalable and flexible solutions, making it easier to implement and manage a data lakehouse. Select storage solution. Choose a storage solution that aligns with your data lakehouse architecture. Common choices include cloud-based object storage services like Amazon S3, Azure Data Lake Storage, or Google Cloud Storage. These platforms provide scalable and cost-effective storage for large volumes of data. Implement data lakehouse layers. Set up the bronze, silver, and gold layers within your chosen storage solution. Design the directory structure and folder hierarchy to organize data at each layer. Define naming conventions and metadata standards. Data ingestion. Implement data ingestion processes to bring raw data into the bronze layer. Use tools like Apache Nifi, AWS Glue, Azure Data Factory, Databricks, or Google Cloud Dataflow for data ingestion. Ensure that data is ingested efficiently and reliably. Define schema and transformations. Define schemas for the silver and gold layers. Implement data transformations to clean and structure the data as it progresses through the layers. Leverage tools like Apache Spark, Apache Airflow, Databricks, or Azure Data Factory to apply transformations. Metadata management. Establish metadata management practices. Capture and store comprehensive metadata for all data layers. Include information about data sources, transformations, lineage, and quality metrics. Use tools like Apache Atlas, AWS Glue, Data Catalog, Unity Catalog, or Azure Purview for metadata management. Implement versioning and historical tracking. Set up versioning mechanisms for tracking changes. Implement historical tracking, such as slowly changing dimensions to manage changes in the data over time. Optimize for performance. Optimize the gold layer for analytical performance. Consider indexing, partitioning, and other performance-enhancing techniques. Choose tools and technologies that support efficient analytical processing, such as Apache Spark or cloud-based analytics services. Implement security measures. Implement security measures to protect data at rest and in transit. Configure access controls to restrict user permissions based on roles. Use encryption and secure authentication mechanisms. Regularly audit and monitor user access for security compliance. Monitoring and operations. Implement monitoring and alerting mechanisms to track the health and performance of data processes across all layers. Monitor data quality, transformation processes, and data ingestion. Set up logging for troubleshooting and diagnostics. User training and adoption. Conduct user training programs to ensure that users understand the data lakehouse architecture, tools, and best practices. Foster a data-driven culture within the organization to encourage effective use of the data lakehouse. Collaboration between teams. Foster collaboration between data engineering, data science, analytics, operations, data governance, security, and business teams. Encourage cross-functional communication to ensure that the data lakehouse meets the needs of various stakeholders. Continuous improvement. Treat the setup of a data lakehouse as an iterative process. Continuously evaluate and improve the architecture based on user feedback, evolving business requirements, and advancements in technology. Remember that the specific steps and tools used may vary based on the chosen technologies, cloud platform, and organizational requirements. It's essential to tailor the setup process to meet the specific needs of your organization. Next, we look at the factors to consider for evaluating the need for data lakehouse. Deciding whether a data lakehouse is the best fit for an enterprise involves a thorough assessment of the organization's needs, data landscape, and strategic goals. Here are key considerations to help make an informed decision. Data, variety, and flexibility. If your enterprise deals with diverse data types, including structured, semi-structured, and unstructured data, and requires flexibility in handling evolving data sources, a data lakehouse may be suitable. Data lakehouses allow for schema-on-read flexibility in the early stages, bronze layer, while providing structured, optimized data for analytics in later stages, gold layer. Analytical workloads. If your enterprise places a strong emphasis on analytical processing, business intelligence, and reporting, a data lakehouse architecture optimized for analytical queries might be beneficial. The gold layer of a data lakehouse is designed for high-performance analytics, providing a structured and organized dataset for efficient querying. Scalability requirements. If your enterprise anticipates significant growth in data volumes over time and requires a scalable solution, a data lakehouse built on a cloud platform could be advantageous. Cloud-based data lakehouse architectures can easily scale storage and processing resources to accommodate growing data volumes. Data governance and compliance. If your enterprise places a high priority on data governance, compliance with regulations, and maintaining a strong data lineage, a data lakehouse with comprehensive metadata management may be suitable. Data lakehouses offer the ability to capture detailed metadata across different layers, supporting data governance practices and compliance requirements. Complex data transformations. If your enterprise requires complex data transformations and cleansing processes to prepare data for analytics, a data lakehouse with a staged processing approach, bronze, silver, gold, can facilitate these transformations. The silver layer of a data lakehouse is an intermediate stage where data transformations can be applied before reaching the gold layer for optimized analytics. Cost considerations. If your enterprise is mindful of cost effectiveness and wants to leverage a combination of cost-efficient storage for raw data, bronze layer, and optimized analytics for structured data, gold layer, a data lakehouse may align with cost considerations. By utilizing scalable and cost-efficient cloud storage for the bronze layer and optimizing analytics in the gold layer, enterprises can manage costs effectively. User skill sets and training. Assess whether your organization has the necessary skill sets and expertise to implement and manage a data lakehouse. Training programs may be required for users to effectively utilize the architecture. Successful implementation and adoption of a data lakehouse require a combination of technical expertise in data engineering, analytics, and data science. Organizational culture and readiness. Consider the readiness of your organization to embrace a data-driven culture. Evaluate whether there is a willingness to adapt to new technologies, workflows, and collaboration practices. Implementing a data lakehouse often involves cultural shifts and collaboration across different teams. Assessing the organizational readiness is crucial for successful adoption. Alternative architectures. Explore alternative architectures, such as traditional data warehousing, data lakes, or hybrid approaches, to ensure that a data lakehouse is the best fit for your enterprise's specific requirements. Depending on the nature of the data and the analytical needs, alternative architectures may better align with certain use cases. Future roadmap and adaptability. Assess your enterprise's long-term data strategy and whether a data lakehouse can adapt to evolving technologies and business requirements. A data lakehouse should be designed with future scalability and adaptability in mind to ensure that it can evolve alongside changing organizational needs. In summary, the decision to adopt a data lakehouse should be based on a comprehensive understanding of the organization's data landscape, analytical requirements, and strategic goals. It may be beneficial to conduct a thorough evaluation, involve key stakeholders, and, if necessary, seek guidance from experts or consultants with experience in data architecture and analytics. To conclude, we outlined the steps to set up a data lakehouse and considerations for enterprises evaluating whether a data lakehouse is the best fit for their needs. Thanks for watching.